Hi folks, so this is question 10. So we've got a function here, so it's the volume of water in a tank and it's measured on a daily basis. So it's starting at day 0. So the volume in the tank can be modeled by this formula. So you're just T is the number of days that you're putting in then. So if you want to know what the volume in the tank is after 1 day, you put in a 1, you put in a 2 for 2 days and so on. So that's what it means. Find the value of T when the tank empties. So empties means that the volume will have to be 0. So this here has to be 0. So we're going to let 0 be equal to it, and then we're just going to solve. So 60 plus 41 T minus 3T squared. Can bring everything to the left hand side. So 3T squared minus 41T minus 60 equals 0. Factorize it. So whatever way you want to factorize it, or you could even use minus b formula if you want. Two numbers that multiply to give 60, so you could have 1 times 60, 4 times 15, 2 times 30 I should have had before that, 3 times 20, and then there's probably a few more as well. I think or there might be a couple more, I'm not sure. Yeah, 6 times 10 as well. You're going to use 4 times 15, so I think it's going to be 15 here and 4 here, and then if we make that a minus, so then 3 times minus 15 would be minus 45, and if you add on 4 then you get minus 41, and we want minus 41 up here. So those will be the factors. So the first bracket is 3T plus 4 and the second bracket is T minus 15. So either 3T plus 4 equals 0 or T minus 15 equals 0. I'll just finish them up here. So 3T is equal to minus 4, therefore T is equal to minus 4 over 3, or T is equal to 15. So we get two answers here, and then you can discount one of them. You can discount this one here, the minus 4 over 3, because T is time in days, remember. So you can't have minus amount of days, so minus 4 over 3 days doesn't make sense. So the answer is T equals 15, so 15 days. So that's the answer to the first part. Second part, find the rate at which the volume of the water in the tank is changing when T is 5. So V of T we know is 60 plus 41T minus 3T squared. So for rate, whenever you see rate, you know that it's going to be a differentiation. So we're going to differentiate this and then just sub in 5 in for T, and then that's going to be it. So V dash T will be, the 60 will be gone, we're left with 41 minus 6T. And then V dash of 5, then we just sub in a 5 instead, so 41 minus 6 times 5 will be, 6 times 5 is 30, so 41 take away 30 is 11. So that's the rate then at which the volume is changing. So it'll be 11, and it's in litres, so the tank is basically losing 11 litres every day. So that's that part. Find the value of T when the volume of water in the tank is a maximum. Right, so V of T is equal to 60 minus 41T. Is that right, or is it plus? Sorry, plus 41T minus 3T squared. Now because you've got a minus 3T squared in here, you know that this on a graph would look like quadratic. We don't really know whereabouts it is, but we just pretend that it's there. It has to go up and down anyway. It has to be that. It can't be like that because it has the minus 3tx squared. So what we want is we want where it's a maximum. So that has to be here. So that's where the line is flat going across the top. So the tangent is there. And then basically what we're getting at is that v dash of t has to be equal to 0 there. So we're going to find t for when v dash of t is 0. So we found that already in the last part. It was 41 minus 6t. So 41 minus 6t. We let that equal 0, so minus 6t is equal to minus 41. So therefore t will be equal to minus 41 over minus 6. And then you can use calculator. And we get 6.8333. So that's recurring. So that's the final answer. So that's the volume when it's at a maximum. Right then, so for part 4 we have to find the maximum volume in the tank, so of the water in the tank. So we know that it's at its maximum when t is this thing here, or 6.8333. So v of t, let's just write out the function again. It's 60 plus 41t minus 3t squared. So all we're going to do is we're just going to sub in into the original function. So we're going to put in this 41. We can put in 41 over 6 because I'm just going to take in this because it'll just be easier to put in than writing what in a recurrent decimal. So it'll just be more accurate. So we can get 60 plus 41 times 41 over 6 minus 3 times 41 over 6 squared. And then it's just using the calculator again. It says they want it to the nearest litre, so you can just round off. So you'll get 200 litres. So 200 litres is the maximum that was in the tank then. So then we're on to part B. Right, so I won't read it all out, so it's fairly long there, but we're given this formula here. So that's the increase of what the tree is, so the increase in the radius of the trunk. So that's the increase of it. And then we're given this here so that the radius after 1 year has to be equal to the radius of 0 years plus the increase, and then the radius of year 2 has to be the radius of year 1 plus the increase of year 2. So that's generally what it means. So it looks fairly long and complicated. The first part, so we have to show that the radius of the trees is increasing year by year. So the increase of t, the increase of the tree, is equal to 1.5 plus sine of pi t over 5. Right, so this is what we have to see. If you think about sine, so if you think about what sine is on the graph, the sine of anything has to end up being between -1 and 1. So you can't get something there within that red circle that isn't between -1 and 1. So the minimum then that this whole thing could be would be whatever 1.5. So if we got, say, -1 as an answer for all of that, so if that ends up being -1, for example, all of it there, so we get -1 inside there, then we have the final function, or the final bit then would be, our increase would be 1.5 take away 1. So 1.5 minus 1, and that's 0.5. So that's still an increase of 0.5. So the minimum increase is 0.5. So there might be other ways as well of explaining it, but that's basically why it has to be increasing, or the radius has to be increasing year on year. Right, the next bit then, we have to show that the increase of year 6 is less than the increase of year 5. So remember, formula for increase anyway is 1.5 plus the sine of pi times whatever the year is. So in this case, in the first one, it'll be 6 all over 5. So that is less than 1.5 plus sine pi times 5 over 5. So straight away we've got there's a 1.5 on both sides, so they'll cancel out. So we're left with sine of 6 pi over 5 is less than sine of, well, the 5's will cancel out there, so sine of pi. Right, so you can put those into the calculator, and if you put sine 6 pi over 5 in, you'll get minus 0.588 when you round it off, and sine of pi will be 0, so that is less. So that's true then. So you've shown that. For the explanation then, you just need to say that all of this here really was the increase in year 6. So that's how much the tree increased by, or the radius increased in year 6. This is all for year 5. So basically the increase in year 6 is less than the increase in year 5. And then that's it. That's all you need to say. Okay. Right, so for this part then, so there's a big long kind of, they write a lot of stuff here again. You can pause and read through there yourself if you want. Basically what we're trying to find out is R2. So that's what we need. So R2. So if you think about it, R2 is going to be R1 plus the increase in, so that's what it is in year 1 plus the increase then in year 2. So that's really what we want. So we want what the radius is after year 1 plus what it increases by then in year 2. So R1 though will be it'll be R0, so that's what it is at the very start before any years happen, plus the increase in year 1, and then we still have to add on the increase in year 2. So R0 then, they actually tell us up here that I think it's going to be 10. Yeah, so shape of radius 10 centimeters. So, and yeah, now it tells you in here as well that R0 is 10. So we know that R0 is 10. So then in order to get what it is after year 1, we just need to add on what it increases by in year 1. So it'll be 10 plus, and we've got a formula for this then, it's the 1.5 plus sin of pi times 1 over 5, and then we need to add on the increase for year 2, so we just put the same thing in again. So 1.5 plus sin of pi times 2 all over 5. Now usually you could just go to the calculator here But if you look back up the question, they actually want you to give the answer in this form here. So they want some number by itself, a, and then they want plus sign of something pi over 5 plus sign of something else pi over 5. So if you just take the three constants that are here, the three numbers by themselves, so 10 plus 1.5 plus 1.5, that will be 13 altogether, plus sine of, we'll just call it 1 pi, just to put it in this form clearly, 1 pi over 5, plus sine of 2 pi over 5. And then it's clearly in that form, so A is 13, B is 1, and C is 2. So we've written it as they wanted it. Right, so for this part anyway, right, so one thing we need anyway is we need to find, so for R10, so section of its trunks in the shape of a cylinder, so we need to find the R10 basically, we need to find the radius after 10 years. So if you think about it from the previous part, it's going to be kind of, remember it said that R0 was 10, so it's going to be that plus the increase after year 1, so that would be 1.5 plus sin of 1 pi over 5, and then that's the, so that's, there is the increase for year 1, and then we're going to have to find the increase for year 2 and add it on, so that would be another 1.5 plus 2 pi over 5, sorry, sine 2 pi over 5. And then it keeps going on, so we could write them all out. You'd only have 9 of them to write out, but it's a good bit of writing still. And it'll go right up until 1.5 plus sine of 10 pi over 5. So realistically then, there's a quicker way of doing this, of kind of figuring out all of that. So if you think about in that space in there, all the way up to 10, you're going to have, think about how many 1.5s you're going to have. You're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The last one will be that last one there. So there's going to be 10 times 1.5. So we've got 10 plus 10 times 1.5 plus, and then it's all of those signs added together then. So sine of pi over 5 plus sine 2 pi over 5 plus sine 3 pi over 5, and so on, all the way up to sine 10 pi over 5. So what you can do is you can do that in the calculator really quickly, and what actually works out really nicely is that all of this in here will actually become 0. So that makes things a lot easier. So all that will end up being 0. So the reason is because if you take all of these, each of them, I think they're all kind of just sine. So the sine of them, it's basically pi over 5 is 36 degrees, because it's pi divided in 5 parts, and that's, if you think about it on the diagram there, pi is over here, so if divided into 5 parts, 1, 2, 3, 4, 5, you've got to get 36, and then what ends up happening is that the first 5 and the second 5 will cancel each other out. You can double check in the calculator anyway, that will just end up being 0, so we get 10 plus, and 10 times 1.5 is 15, so we just end up getting 25 here. So 25 will be the radius after 10 years. Right, so we still need to find out what k is. So we know that v2, that's the 10-year tree, is equal to k times v1. So that's the very first one. Or yeah, that's what it is at the start. So v2, so volume of a cylinder anyway, is pi r squared h is equal to k times pi r squared h. So that's going to be the second radius, and that's going to be the first radius. So that's what this is what it is after 10 years. This is what it is right at the start. So because there's pi's and h's on both sides, the pi's will cancel out, the h's will cancel out because they're going to be the same thing. Yeah, we're left with k then. So k is going to be what the second radius is squared over, just bring across the r1, so you got r2 squared over r1 squared. So that's what k is. And then you can put them in. So r2 is the 25, so 25 squared, and r1 is just 10 squared. That's what it is at the start. So just checking what they want us to round it to then. So it doesn't really say, it just says k is an element of the reals, so we can just leave in 25 squared divided by 10 squared will be 6.25. And then that's it. And then that's all for that question.